Hello judges, my name is Malika Kobayeva and today I'm going to present you my scientific project called Pullulan-based coatings for food protection. So let's move on to next slide with content of the presentation. So presentation contains aim and objectives, relevance and practical significance, introduction to Pullulan, advantages of the Pullulan-based coatings, antifungal activity in vivo and in vitro, scheme of the biosynthesis and extraction of the Pullulan, results and conclusions. The aim of the work was to evaluate the possibility of using Pullulan coating based on the yeast-like fungus Aeropygidium pullans to protect food products. The objectives of the work were to assess the antifungal activity of culture fluids of Aeropygidium pullans in vitro and in vivo, and to obtain the Pullulan films and determine the possibility of application to preserve the quality and increase the shelf life of fresh berries, as well as to protect against phytopathogenic fungi, Sphaerides cinerea. So let's move on to relevance and practical significance. What is the point of my project? Nowadays, humanity produces over 360 million tons of plastic every year, and some reports indicate that up to 15% of that is for single-use purposes. Reducing this vast number is a priority in the fight against plastic pollution. And my project offers you a biodegradable analog of the plastic, which is Pullulan. Fighting solution against plastic pollution is included in Sustainable Development Goals number 3, 6, 11, 12, 13, 14, and 15. So it's very crucial and relevant in our times. Let's move on to introduction to Pullulan. What is the Pullulan? Pullulan is an exopolysaccharide with microbic origin, producing of which is Aeropygidium pullans. It's transparent, form gel, and tasteless. It's semi-permeable to oxygen, it's water and fight resistant, also it's resistant to mechanical damages. Pullulan is a probiotic and perform antifungal and bactericidal functions. Pullulan is edible, digestible, and tasteless. On the next slide, you can see the series of the pictures which introduce you to the process of the extraction and purification of the Pullulan. So on the first slide, you can see the beaker with the Pullulan and ethanol. On the second, you can see the beaker with glass stick, which Pullulan is wrapped around. And the last slide, you can see the dried state of the Pullulan on the rubber coats, which will then be turned into powder. On the next slide, you can see the advantages of the Pullulan. So what is the point of using Pullulan? First advantage of the Pullulan is that it can be not removed from the product. So compared to the other types of biodegradable analogs of active packaging, it's safe for eating with the product. So you can choose to not remove the coating from the product, and it will be okay. Then the second feature is that it inhibits the development of pathogen. So again, it's active packaging and not only serve as against mechanical damage, but also controls the growth of the phytopathogens. The next feature is that it preserves the natural aroma, color, and flavor of the product, which is also important in case of sales. For example, if you take the food product with some coating that will interfere with the visible structural integrity, it will reduce the sales, but Pullulan will not affect anything. Let's move on to antifungal activity in vitro. Germination of Canidia and growth of the phytopathogen were suppressed by the culture fluids of Aeropygidium pullans after 72 hours of cultivation. And experimental variants showed signs of inhibition from the 15% after 24 hours of cultivation to 34% after 72-hour cultivation, and also inhibition of germ tube elongation by 25% by 72 hours. Let's move on to antifungal activity in vivo. When treated with 24-hour filtrate, the diameter of the infected zones was 6.22 millimeters, and then this index decreased with increasing age of the filtrate. So after 72-hour filtrate, this index was 3.7 millimeters. On the next slide, you can see the scheme of the synthesis and extraction of the exopolysaccharide. So we took the C7 strain and grow it in the nutritional environment, which is sub-raw. Then we cultivate it in shaker for 7 days and put it in the centrifugation machine. Then it divides the mass to biomass in supernatant. We took the supernatant and dissolve it in alcohol in ratio 1:2, and then we took the exopolysaccharide, then purify and dry it. On the next slide, you can see the titration table, which compares the different types of coatings effects on the samples based on their visible integrity structure, color, and mass. The second table shows the surface color changes of strawberries from day 0 to day 14. The study on the possibility of using Pullulan coatings to protect food products led to the following conclusions. The inhibitory effect of aeropositin Pullulan's cultural fluid metabolism on the growth of the Phytopathogen Patricinerea in vitro was shown. So the number of the germinated Canidia was reduced by 34%, the germ tube by 25% after 72 hours of cultivation. Evaluation of antifungal activity in vivo showed that the diameter of the berry lesions was reduced by 35% by aeropositin Pullulan's culture filtrates. Food films based on 1.2% Pullulan solution and 0.3% glycerol and gelatin solutions were obtained. It was shown that Pullulan coatings provides production of strawberry weight loss by 25% and increase of its shelf life up to 10 days. That's it. That's the end of the presentation. Thank you for your attention. Bye.